Okay, well today we're going to talk about lesson chapter 6-6, which is systems of linear inequalities. Okay, the objective is to solve systems of linear inequalities by graphing and to model real-world situations using systems of linear inequalities. Okay, A1.3.2 is our standard. Okay, systems of linear inequalities are two or more linear inequalities graphed on the same coordinate plane. So just like systems of linear equations was two or more equations, this is just two or more inequalities. Okay, solution is the shaded region formed by the two or more linear inequalities. That'll be more clear once we see an example here. Okay, so key concept is system of linear inequalities, exactly the same as linear inequalities, just now we'll be graphing two or more. Alright, so some things we have to note, or simple recap, is that if it doesn't have a solid line, so it's less than or greater than, then what we're going to have is a dashed line. So no solid line, dashed line. Solid line, so greater than or equal to or less than or equal to, would be a solid line. Okay, so an example of a graph would be we have a line running here. I know it's kind of hard to see, I got a lot of lines here, but a line running across here, and we're shading downward in this kind of grayish green section, and it goes up into the yellow section. And then we have a red line that's going across here that's represented by this purple and yellow section here. Okay, you can't see the purple underneath the yellow, but it's there. Okay, so the solution area is where it overlaps, which is represented by the yellow. Alright, colors don't matter, I'm just putting those in there. But the yellow would be the overlap. So that's what we're going to be doing, is we're going to be graphing those types of systems. That's what it's going to be looking like. So the yellow region is your solution. The whole graph is part of the solution, but the yellow is the solution area. Alright, so let's talk about what is the graph of the system. So we're going to do the same thing. We're going to start. And again, it's just like equations. If you want, you can think of this as y equals 2x minus 3 and graph that and then make a dashed or solid line based on what you need. So minus 3 means I'm down 3 from my first point. So I'm going to graph that first. My slope is 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, or even down 2, back 1. Okay, so there's my line, my first one. Now, what I want to do from there is I want to shade one side of this. Now its y value is less than, so a little shortcut here is all the y values that are less than that line are down here. So I want to shade down. If you want to check, we do the test point and probably use 0, 0 again. So if I put in 0, 0, I get is 0 less than negative 3. Well, that's not true. 0 is actually greater than negative 3. So that just shows us we're going to shade down in here. So what I'm going to do is I'm going to shade using some lines here to represent my shading. Okay, so this is my shaded region down in here. Alright, in blue, put this in blue, I'm going to do the next one, which probably x and y intercepts would be real simple to do this one. So if x is 0, y is 2. So I go up 2. Okay, if y is 0, x is 1. So I'm here at 1. And then I'm just going to draw my line. Okay, still a dashed line. So again, I'm just going to go right through. If I can draw a straight line. A little harder than what it seems. Okay, so there's my line. And then I'm going to do the same thing. Maybe pick 0, 0 again. So I'm going to say like 2 times 0 plus 0. Is that 0 greater than 2? And I would say no, 0 is not greater than 2. So I'm going to shade away from 0, 0, which means I'm going to shade this way. And what we're looking for is that overlap. Now that overlap is going to be our shaded region. Okay, so this is going to be our overlap. And we're going to shade that section of the graph. So just shade this up a little bit. And that's our solution area. Okay, That's what we're looking for in our system of inequalities. So you're just going to graph two different inequalities like we did the previous lesson. You're just going to graph them on the same Cartesian plane, and then the overlap would be you shade it in with a different color or shade it in real dark to represent the shaded region. But I need to clearly tell the difference between the first graph, the second graph, and the overlap. So maybe colored pencils or hash marks, things like that. Okay, so we've got example number 2, I want you to go ahead and do. All right, and problem number 2, we're actually going to write the equation. So writing the equation. So let's just start with the first one, this solid one. That just seems like an easy one to go with. We're just going to start by analyzing it. Well, I can tell it looks to be crossing at -1. So if I were to put this in y equals mx plus b, I see my b is going to be a -1. And then if I go up 1 over 1, up 1 over 1, up 1, it looks like my slope is 1. So I'm going to put 1x. So there's my equals. Now all I have to do is make it an inequality. Okay, so it looks like this blue shaded region is what I'm looking at, and it's shading up. So it looks like those are all the y values that are greater than that line. So I'm probably going to say greater than or equal to. Now I can check that by going through and plugging in again 0, 0, and say is 0 greater than -1? We say yeah, that is a true statement. Okay, I'm going to change that. Kind of bugging me if it's not. There we go. Alright, so there's my first system. So now I need to go to my second one, which is this one right here. Now it's clearly not going to have a solid line because it's dashed. But I'm going to do the same thing. I'm going to put y, and I'm going to analyze it. It looks like right here, so that's 1, 2, 3, 4, 5. So it looks like a +5. My slope looks negative, so I'm going to check that. It looks 1, 1, 2, 1, 1, 2, 1, 1, 2. Looks like a -1/2 x for my slope. Now it's represented by this yellow section. So it probably means that it's going to be y is less than, again, no solid line. Again, we pick 0, 0 and say 0 less than 5. Yeah, that's true. So there would be my system. Okay, so it's just going by identifying the y-intercept and going from there. Find your slope and then determine which way you want to shade. Okay, so got it number 2. I want you to go ahead and do. Alright, let's look at problem number 3. You're planning to do what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. So together, so let's go ahead and say like x is b-ball. Okay, y is homework. At most, you can do x plus y. You can spend at most 6 hours, which means what? Well, that means that this can be no greater than 6, but it can be equal to. You want to spend less than 2 hours playing basketball, so it means x, you would like to spend less than 2 hours. You must spend at least 1.5 hours on homework. So that would be y is greater than in that case. Okay, so this one actually brings up a system of 3 equations. So let's start with the one variable ones because those are pretty simple. We'll go to this first one to be in blue. It says x is less than 2, so there's 2, and we have a dotted line going straight up and down. There we go. And it's less than, which means we're going to shade this way. Okay, so I'm going to go ahead and shade that way. Now I only shade the 0 because this is time, which means that obviously you can't have negative time. So I just stayed in that first section. The next one, let's put that in red, the y. Y is greater than 1.5, so there's 1.5. And that is greater than, so it is a solid line. And it says greater than that, so we want to shade up. So if we shade all the way up, I'll draw that. Right now our solution area is this little rectangle right here. Okay, but we got to do this one here. I'm going to put that in green, which is x plus y is less than or equal to 6, which means if y is 0, x is 1, 2, 3, 4, 5, 6. In the same way the other way, 1, 2, 3, 4, 5, 6. So what that means is that we're going from there to there, and it's less than, which means we're shading down this way. Now this gets really messy really quick, but what we should find out is that there's a connection right here of overlap. Okay, and that would be our shaded region. And let me make that darker. So that would be the graph of what we could do. Okay, so that's how you work through it. You just do it one at a time, and then you just find the overlap. All right, we'll go ahead and stop there for this lesson. Pretty simple if you follow the instructions of going through the systems, just one inequality at a time. So if you did well on the inequality section, you'll be fine in this section. Okay, if you have questions, let me know. Again, you have the pre-quiz, and then also we'll have quizzes in class, and you also check some extra examples that I'll put up online as well.